Now that we know a whole bunch about similarity, our next goal is going to be how to prove that two objects are similar to each other. So we know what the definition is, and that is that two polygons are similar if all pairs of corresponding angles are congruent and all pairs of corresponding sides are proportional. However, just like when we were talking about congruence before with triangles, we know that there were some special ways or some shortcuts to prove the triangles are congruent. Well, the same is going to be true for similarity as well, where we're going to have a few special ways or shortcuts that we can use to be able to prove that two triangles are similar. So the very first one that we have is the angle-angle similarity postulate. It says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles have to be similar. So let's go ahead and take a look at why that is. I'm just going to draw two triangles really quick. Here's one. We'll name it. And then we'll draw another one. They look like they're roughly similar to each other. Okay, so the first question you might be asking yourself is, this is really close to our definition, which is all pairs of corresponding angles congruent and all pairs of corresponding sides proportional, but I'm missing the third angle. So if I know that I have, let's say, angle A and angle D congruent and angle B and angle E congruent, why do I not also have to say that angle C and angle F are congruent? And the reason is because of something we've learned previously, which is the third angles theorem. We know that if two pairs of angles are congruent between two triangles, and the third pair has to be congruent as well. So the third angles theorem allows us to not have to go all the way to angle, angle, angle. We can just have angle, angle. And so if I have two triangles with two pairs of angles congruent to each other, it means the third pair has to be congruent. So that satisfies half of our conditions here. And so the other part is this proportionality between the sides. And we're not really going to be able to justify that right now. We need to talk about something that we'll talk about later, which are dilations and their type of transformation. But we can see that if we were to kind of take this triangle here, triangle ABC, and expand it out, if it has all the same angles as triangle DEF, that they will end up matching up with each other. And so we'll actually justify this kind of a little bit later. But for now, we're just going to suffice to say that if we know that two triangles have two pairs of corresponding angles that are congruent, that is enough to say that they are similar to each other. And so when we go to prove this, when we try to prove that two triangles are congruent, that's all we need to say before we can use the angle-angle postulate to then prove that the triangles are similar to each other. So it's as simple as that. That's our first postulate that we have to prove that two triangles are similar, but we'll learn a couple more as we go.